what capabilities does QCS have that are helpful for accelerating quantum experiments?
Yeah, I can take that one. So yeah, there are several capabilities added into this solution that specifically tuned for the quantum control system. And I'll be touching main of them. Um, Number one is the HVI IP, which is at the heart of the system. HVI IP is a Keysight proprietary IP that adds various capabilities to the system. Um, Number one is the synchronization. So what it does is that, I mean, it's a modular system. So there are several modules, several chassis in the system. So what HVI IP does is that it uses the synchronization signals from the PIXI backplane and align all the modules so that all the modules in a chassis or in a multiple chassis act as a single coherent system. And this also sets the time zero of the system once everything is synchronized. Once time zero is set up, the other capability that HVIP adds is the time determinist. So everything after time zero is time deterministic. We write the script, we add the things that we want to do in our test, and everything is precise and time deterministic. Will happen exactly at the time that we expect and we programmed. The other capabilities that it adds is various instructions to like play the waveform, generate a trigger to play the waveform, or generate a trigger to capture the waveform at a deterministic time. It can do phase or amplitude change at a very precise time as per the time set up in the script, and it can change the output to the baseband, or it could be IQ modulation, or it could be a simple carrier frequency transmission. The resolution of all these instructions being executed is very fine. It's 3.33 nanosecond. So this entire HVI IP is a big state machine running in the FPGA, and then it's all it fetches the instructions on every clock cycle and execute it in time deterministic manner. Some other capabilities that has been there is the low latency. We know that the quantum control system has to have low latency. The latency is very critical for a quantum control system. So the overall system and every individual block has been specifically designed to keep the latency low. The next one is the fast data sharing. Fast data sharing is a link between one module to another. It's basically a low latency sandbox to sandbox communication link that enables quantum feedback operations. So yeah, these are the various capabilities, many of them, and that basically tuned for a quantum control system.
Thanks. And since you mentioned fast data sharing, can you talk a little bit more on that and tell us, how do these cards talk to each other for things like fast feedback operations?
Yeah. So this fast data sharing is developed to enable the quantum feedback operation. This is a link between one module to one or more modules where this quantum feedback operations are being sent. So it utilizes the D star lines over PIXI backplane or a front panel connector called the system link connector that to transfer the feedback results from one module to another. So referring this diagram, let's see how through step by step how the things goes on and where the fast data sharing provides a feedback operation. So initially the HVI at the M5300A AWG RF AWG generate a trigger to make it send a RF pulse, a RF readout pulse. So that readout pulse will be sent to the qubit. The qubit will respond, and the response RF signal is given to the to the M5201 a digitizer down converter, where it's down converted and IF signal has been generated. This IF signal is actually sent to the digitizer, where the HVI generates another trigger to sample only the part of the response that we want to sample and digitize. So this response, this sampled waveform, go into the sandbox of the M5200A digitizer, and there the quantum feedback, the quantum state can be computed there. The quantum state is sent as a feedback over this fast data sharing link, and the system synchronization module M9032A or M9033A act as a deterministic latency router there. So they route the feedback results from one or more digitizers to one or more RF AWGs, and the feedback result is feedback through this fast data sharing link to RF AWG, and in RF AWG, HVI generates another trigger at right time because it knows the latency of this entire fast data sharing link. HVI knows the latency of every fast data sharing link in the system. So it generates the trigger at appropriate time when this feedback information is available, so that a new RF pulse has been computed in the sandbox of the RFAWG, and then that RF pulse is sent as a control pulse to the qubit. So this is how this entire loop works, and that's how the fast data sharing adds value to share the quantum feedback results. And this capability has been added into the hardware, and the more software and gateway capabilities will keep coming in upcoming releases.
Yeah, that makes a lot of sense. Thank you, Atul.